So in this video, what we are going to see is phase 3. So if we recall phase 2, we know that in phase 2 we have seen that we can perform error handling as well as paging, and we have implemented virtual memory. But now the more important concept that deals with operating system is multi-programming. We have to understand that multi-programming is the feature which allows us to advance in computation so much that today we are working upon supercomputers and quantum computers. If we would not have been able to figure out multi-programming, then it would have been impossible to further progress in operating systems. So let's see how phase 3 implements multi-programming, because we have seen that phase 2 has a lot of advancements, but phase 3 is a step ahead of it. So just consider a scenario where we know that we have an input buffer. Suppose we have an input buffer. Sorry, my bad. So we have an input buffer. Sorry, we have a card reader actually. Suppose that in my operating system, I have to take the data as input. So my card reader is going to take that data as an input through card reader. And what would happen is, we have seen that already, that it would be stored somewhere, and then it would be stored in it would be stored somewhere temporarily, and then it would be sent to a secondary memory, right? Just consider this as a secondary memory that we are referring to, and that's the flow. And suppose if we have to display the data, then from that secondary memory we would load that particular data, and after loading that particular data we would display it through any output devices such as printer, console, or anything else. But the thing is, it does not allow us to implement multi-programming, right? Because we know that one program only can exist at a particular instance in our memory. So for that, what we do is, rather than considering this as a main memory, we consider this section as set of queues and buffers. So just consider this as a queue, a set of queues. Now where first thing is buffers, second is empty queue, third is input queue, and fourth is output queue. So I'm just showing you that these are the kind of queues and buffers that exist actually in our system. So this is something that we replace our system with. And apart from this, we have our main memory here. And apart from this main memory, we have our central processing unit, that is CPU at this side. So these are the registers that we would have. This is the CPU that I have. This is the main memory, and this is the system that I have. But just think, what if I have to simultaneously perform more than one operation, right? What does it mean is, suppose I'm writing something and at the same time I want to read something, right? So my printer, I know that my printer and my card reader, these are two different entities. Now they can work together, right? They can work separately, they can work simultaneously, because they are not independent, they are not dependent on each other at a particular instance. So for that, to bring this synchronization, we provide an interface between these entities, and this interface is known as channel. So this is channel 1, this is channel 2, and this is what we call as channel 3. Now you can understand what I was talking about. Suppose that I want to perform a reader operation, a reading operation. So my card reader would be activated. So how would my system know that my card reader is getting activated and I'm working upon reading operation, right? So for that my channel 1 is utilized. What about writing operation? So I know that whenever my printer is to be used, I would activate channel 2 to access the particular data and indicate that my writing operation is going on. But you must be saying, okay, that's fine that you have channel 1 as well as channel 2. But what is the use of channel 3? So let me tell you that channel 3 is the most important part of our system, because it will be included in reading operation, it would be included in writing operation, and it would be included in GD and PD operations too. Get data, input data. So let's get a bit technical. So what would be the flow of our data? So always remember that my card reader would go to channel 1. The data from card reader would go to channel 1 and it would be loaded into the buffer. After getting loaded into the buffer, it would be loaded into the empty queue, and after getting loaded into the empty queue, it would be loaded into input queue, because I know that this is not something I'm going to print as an output, but I'm going to store as an input. So this is the flow from card reader to channel 1, from channel 1 to buffer, then empty queue. Buffer is of 10 units. Always remember this. From empty queue, it is going to get into input queue. Right. Now, after getting into input queue, I know that where my data is going to go. Right. So in that case, what I'm going to do is I'm going to send this input queue to channel 3. And after sending this data to channel 3, the communication would happen between main memory, drum, CPU according to the need of ours. Means suppose if I want to perform some particular operation upon my data. So after loading this data of input queue into channel 3, my input queue would be freed, my data would be in channel 3. I would be placing it into the main memory. Then to perform operations, I would be sending that data from main memory to CPU. CPU would perform arithmetic and logical operations. It would return us the processed output, and that output would be returned to channel 3, and that channel 3 would be sending that data into our drum. And what does this process mean? So this process means spooling, and that is input spooling. Always remember that whatever we are doing here, it is known as spooling. The data from the card reader is loaded into channel 1, and channel 1 sends it to buffer sends it to MTQ sends it to input queue frees itself by sending the data to channel 3, and after that a drum, main memory and CPU coordinately work upon it to provide us the satisfying output, right? But you must be saying, okay, this is correct, but what about the output? That suppose I have to display something, suppose I have to display something on printer or console. So what to do in that case? So it is as simple as you can imagine. Now just consider that we are not going to do anything with the card reader in that case, because we know that the data that we are going to display can either exist in our main memory, and certainly it is going to exist in main memory itself, because the data cannot directly be accessed from secondary memory, but we know that permanently it is stored in drum. So what we would do is, you take that data from drum, we would load it into channel 3, and after loading that data into channel 3, what we would do is we would send it to output buffer, right? After sending it to output buffer, since my output buffer is loaded, just it's pure coordination, right? I would send it to channel 2,